Good morning, children. So we had discussed the chapter symmetry in the last class, right? So I had completed till the 6th main exercise. So we'll see with the 7th main problem. So state the number of lines of symmetry for the following figures. So you have to say how many lines of number of symmetry will be there in the given figure. See, they are given you J. Till J it is there equilateral triangle, isosceles triangle, scalene triangle. So for this, how many lines of symmetry will be there, you have to say. Okay. So first one is an equilateral triangle. Equilateral means what? Equilateral triangle means what, children? Equilateral triangle is nothing but a triangle which has all the three sides equal, right? That is called as an equilateral triangle. So how many lines of symmetry will be there in equilateral triangle? See here. Equilateral means we know all the sides will be equal. So if all the sides will be equal, there will be one line, then two line, and one more, three lines of symmetry will be there. So how many lines of symmetry will be there in equilateral triangle? Three lines of symmetry. When you are writing in a notes, no need to draw the diagram. That is for your reference. If you want, you can draw it, or else in front of question you will write three lines of symmetry. Okay. Next, an isosceles triangle. Isosceles means what? Two sides are equal, right? So one side and two sides. These two sides will be equal where this is different. So how many lines of symmetry will be there? This will be having one line of symmetry. It will be having how many lines of symmetry? One line. I can't put from this side because this side is different and this side is different. So it will be having only one line of symmetry. Next is scalene. Scalene means what? All the sides are different. So can I draw a line of symmetry for this? No. So this is having zero. So zero line of symmetry. Next one, square. You know square. Square means what? All the sides are equal, right? See, all the sides are equal. So if all the sides are equal, it will be having how many lines of symmetry? 1, 2, then one more 3, then one more 4. So how many lines of symmetry will be here? 4 lines of symmetry. Clear, children? Next one is rectangle. Rectangle means you all know opposite sides will be same. Opposite sides length will be same. So this will be having a line of symmetry. One is here, another one is here. So totally how many lines of symmetry? 2. I can't draw like this because all the sides are not equal. So only 2 lines of symmetry will be there. Next, rhombus. Rhombus means how? You all know rhombus is like this. So rhombus will be having 1, 2. So 2 lines of symmetry. Next one, a parallelogram. Parallelogram is like this. So can I draw a line of symmetry for this? No. So here 0. So line of symmetry will be 0. Next one is quadrilateral. Quadrilateral means how the quadrilateral will be? Any one which is having 4 sides like this. So in quadrilateral there are so many types which I learned. Parallelogram, rhombus, trapezium, all this comes. Can I draw a line of symmetry for this? No. So it is 0. Next one, hexagon. Hexagon means it will be having how many sides? 6 sides. Where 6 sides are also will be having same length. So how many lines of symmetry will be there? 1, 2, 3, 4. Then can I draw any other places? See, 5, 6. So how many lines? 6 lines of symmetry will be there in circle. Sorry, it's hexagon. Next one, circle. So circle will be having so many number of lines of symmetry. See, all this in the point it should be coinciding. See, so this will be having infinite, means we can't count. Some number of infinite number of symmetry will be there. Okay. Now write letters of English alphabet of reflection symmetry, that is symmetry related to mirror reflection about. So vertical mirror, horizontal mirror, both vertical. So in front of the mirror, you keep the mirror as vertical and see how the alphabets look like that. You will write down. Any alphabets you can take. For example, I will take it as for this vertical A, H, M. So when you keep in front of the vertical mirror, it looks like M, H, A. Ulta, just that's all. Okay. Next, one horizontal means like this, upside down, UVW. So when you keep how it looks, UVW, it looks how it looks. You have to keep right on like that. Next, give 3 examples of shapes with no line of symmetry. By your own, you will write down any 3 examples for this. Okay. Next, what other name can you give to the line of symmetry? So, what other names you can give? First one is an isosceles triangle. Isosceles means you all know what? 2 sides will be same. See, these 2 sides will be same, one will be different. So, they are asking, what other name you can give to the line of symmetry? What is this line of symmetry? This. We know from this point to the middle, we are going to call it as in what this is called as? This is called as an median. So, you can write on here median. Same coming for the circle. Circle is like this. This line from here to here, it is called as what? Diameter. It is called as diameter. Clear? Now, the new concept is rotational symmetry. So, what do you mean by rotational symmetry? You can see the picture of clock, right? In clock, in which direction does it rotate? Does it rotate backwards or frontwards? Frontwards. So, we are going to call that rotation as clockwise direction. Okay, if it goes backwards, we are going to call it as an anti-clockwise direction. Okay, so don't get confused between clockwise and anti-clockwise. Going forward is called clockwise and going backward is called as anti-clockwise. Okay, so this point, which is the center which is from rotating, we are going to call it as a center of rotation. Right, this is the main point. So, this is called as what? Center of rotation. Okay, so whatever it rotates, we are going to call this as an angle. So, angle of rotation, right? For example, 2 o'clock means it starts rotating. So, when it rotates, there some angle will be forming, that is called as angle of rotation. Clear? Now, we are going to say one complete turn will be given by how many values? 360 degree. Right, complete angle is nothing but 360 degree. So, complete rotation means 360 degree. So, half means 180 degree. Right. So, quarter turn means 90 degree. Right, 90. See, for example, from here to here 90, 180, 270, 360. So, you should be knowing quarter, half, 3/4, full. Clear? Now, the point is, what do you mean by rotational symmetry? Rotational symmetry is nothing but if you rotate at a fixed point to 90 degree by 90 degree about a fixed point, that is called as 90 degree. For example, this pencil is here. Okay. Now, I should rotate this pencil one rotation, or otherwise you have to rotate it one order of one. Rotational symmetry means, see, 90 degree from here to here 90 degree means this. So, this is your rotational symmetry. Okay, got the concept? So, rotational symmetry is nothing but, see here, just you can see, observe here, this is a pen. Okay, you rotate this in order 1 of rotational symmetry means it should be 90 degrees. So, rotate it to 90 degree. This is your order 1, that is rotational symmetry order 1. Next, order 2 means 180 degree. So, this is 180 degree, that is rotational symmetry of order 2. Next, rotate, this is 270 degree, it is order 3. Then it completes one round, we are going to say it is order 4, then it is 360 degree. Clear, children? So, rotational symmetry is nothing but if it rotate by 90 degree, about a fixed point, then it is called as rotational symmetry. So, in one full turn, how many positions will be there? 4 positions. So, first is 90, 180, 270 and 360 degree. Clear, children? Did you understood? Yes. Now, we can see the exercise problem. Page number 122, exercise 2. So, first main is, which of the following figures have rotational symmetry of order more than 1? So, you have to say which of the followings have more than order 1. So, this is circle means it can rotate 1, 2, 3, 4. Therefore, it is, yes, it is a rotational symmetry. Next, triangle is there. So, once you can rotate 1, then 2, 3. So it is more than 1. So here you can write yes. This, can it rotate twice? No, only once it can be rotated. So it is no, it is not a rotational symmetry. You have to write on yes, it is a rotational symmetry. No, it is not a rotational symmetry. Next, this one. When I turn like this, will it be rotational symmetry? Yes. It is a rotational symmetry. Then circle, is it rotational symmetry? Yes. Does this figure is rotational symmetry? Yes. See, when I rotate, same shape is there, same shape. So it is rotational symmetry. It depends on the same size, shape, everywhere. When you rotate, again same shape, same size should be there. Okay. Now, give the order of rotational symmetry for each figure. Okay, they have given you some figures, you have to give the order of rotation. So let me see. First one you can see it is like this. So first picture they have given you in the question like this. Okay, so first I'll write down the question like this. First one. So first I rotate this two in this direction. So when I rotate, what happens? This go upside down, right? See, again. So how many order of symmetry is here? 2. Same, this is also 80 degrees here. Okay. So 80 degree means rotate it. So first like this it will be 80 degree. So first rotate it. So when I rotate, what it becomes? Upside 80 becomes downside 80. It should be rotational symmetry, no? So it has to be half rotation. So how many order symmetries here? 2. Next, triangle. See, for example, if you want, you can name it, either I'll name it as A. So first A is here. Next, see, this is a question. A. So first, this is A point. So when I rotate, what it becomes? A comes this side. Second rotation. Now A comes this side. So how many? 1, 2, 3. So this represents, A represents the starting point. Okay. Now same here, see, I'll take it as P, Q, R. Yes, I'll name it for all. Now you rotate one. So P is there. First I'll rotate this P towards this side. Okay. So when I rotate P, so this becomes P, Q, R, S. Again if I rotate, so P becomes here, P, Q, R, S. So again I rotate this. So where is P now? Here. So P goes here, P, Q, R, S. So how many rotations are there? 1, 2, 3, 4 rotations. So order of rotation is 4. Okay. Next one, E1, that is plus sign. See, I'll name it now, M, N, O, P. So when I rotate, same happens, takes place. Just I am drawing it rough diagram. Please draw it neatly. M, N, O, P. Again when I rotate, M comes down. So M, N, O, P. Again when I rotate, from here M goes to there. M, N, O, P. So how many rotations? 1, 2, 3, 4 rotations. Okay. Until it comes full, complete 1 rotations, you have to rotate it. Now I'll name it as A, B, C, D, E. Okay. So first A is here. Next A changes to here. A, B, C, D, E. If you want, you can cut the color papers and paste it. Next again. A, B, C, D, E. Again. Here A is here. Next point A, B, C, D, E. Next A goes to here. A, B, C, D, E. How many rotations? 1, 2, 3, 4, 5. Right. So how many it is? 5 rotation. 5 lines are symmetry. Okay. So same. Please give the names A, B, C, D, E, F like this and draw. Okay. So first A will be there. When you rotate, it comes here. Again, when you rotate, it comes here. Again, when you rotate, it comes here. So how many rotation takes place? 1, 2, 3, 4, 5 and 6. So how many symmetry will be there? 6 symmetry will be there. Clear, children? Yes. Next exercise, that is page number 123. Name any two figures that have both line symmetry and rotational symmetry. Line means when you draw it should be half. Rotational means when you turn also it should be half. So they are asking you to name any two figures. So which are those two figures? One is circle and another one is triangle. Okay, circle and triangle. So draw wherever possible a rough sketch of a triangle with both line and rotational symmetry of order more than 1. Okay, so how you will draw this? So you should draw a triangle with both line and rotational symmetry of order more than 1. So order more than 1 means you should take equilateral triangle. Right, see equilateral triangles means you know all the sides are equal. So this is a triangle. How we are going to draw a line of symmetry for this? This is the line of symmetry. Right, one more line of symmetry is this. And one more line of symmetry is this. When you are drawing, take all the sides same length, you will get it neatly. Okay. Next, how we are going to write rotational symmetry for this? See now, take a triangle. I'll just name it as A, B, C. So when I rotate, what happens? So first rotation from this side to this side. So A becomes drawn. A, B, C. Now again, you rotate it. So from A, there goes to A, B, C. This is a rotational symmetry. Now, second question. A triangle with only one line symmetry and no rotational symmetry of order more than 1. So, can we draw it? No. It is not possible. It is not possible. Why it is not possible? Because order of rotational symmetry is also more than 1. Because order of rotational symmetry is more than 1. So, okay. Next. So, first and 2 is enough. Third, fourth and this third one, this drawn one. Okay. Next one. This tabulation column. Fill in the blanks. See shapes they are given. You have to say center of rotation, order of rotation and angle of rotation. Now square. You know square. Where the center of rotation will be there? It will be in interior. It will be in interior region. It will be in interior region. What is the order of rotation? You know square, right? Square, for example, you take now, you consider this book as a square. So, order of rotation 1, 2, 3, 4. So, what is the order of rotation now? 4. Okay. So, when it rotates, what was the angle? It is 90 degree. Next, rectangle. Rectangle also in interior region. Order of rotation is only rectangle can be rotated into 2. What will be the degree? It will be 180 degree. See here now, this book is in rectangular shape. Right, this book is in rectangular shape. Now I'll keep it like this. If the line of symmetry, you know, this is line of symmetry and this is line of symmetry. When it comes to angle of rotation, is this is angle of rotation? No. Right. If this is like this, again it should come like this. So 1, 2. So what is the 2? How many degrees you are rotating? See, 90 degree, 180 degree. So you will write down it as 180 degree. Okay. Next, rhombus. Rhombus will be in which shape? Rhombus will be in this shape. So it will be also in interior region. Order of rotation is 2. And the angle of rotation is 120 degree. Next, equilateral triangle. In equilateral triangle, center of rotation is called as median. So triangle always it will be 3. Degree will be 120 degree. It is 120 degree. Next, hexagon. For hexagon also it is in interior region. Interior means inside, right? In inside only the center of rotation comes. What is the number of rotation? For hexagon, how many sides are there? 6. So order of rotation will be 6. So the angle of rotation will be 60 degree. Okay. Now circle. Which is the center of rotation? Center. That is O. Order of rotation is infinite. And angle of rotation is at any point. At any point it can be there. No, we can't say all for 1 degree, for 2 degree, 3 degree, 4 degree. It goes on coming. Next, semicircle, which is, it is midpoint. Order of rotation is only 1 and degree is 360 degree. Okay. Now, name the quadrilateral which are both line and rotational symmetry of order more than 1. So in quadrilateral you have to name any one quadrilateral. So in quadrilateral there are so many types, right? Which are those types? Parallelogram, square, rectangle, trapezium, rhombus. So in this quadrilateral which has both line and rotational symmetry is nothing but square. It is square. Clear, children? Yes. So till here you complete it off the notes and please submit it, take a photo and send it to me. I'll be telling you shortly when to give the notes for correction. Okay, children? Thank you, children. Please stay in your homes. You know that day by day the situation is becoming very worst. So please take care of your children. Thank you.